Right, thermodynamics. We've just done some revision on Hess's cycles and the like. We've also looked at some new definitions about energy change during chemical reactions and the types of reactions that we can use in these calculations. The next new area of this thermodynamics topic is enthalpy of solution calculations. In essence, what it is the formation of solutions. Now, the easiest way to make a solution is to take an ionic substance, ionic solid, and put it into water, and it dissolves, and what we get is dissolved ions. Now, sometimes, for instance, some of the salts just don't dissolve, and the one that should spring to mind is barium sulfate. So in the case of barium sulfate, we just can't measure this delta H of solubility value. So just like when we looked at Hess's cycles before, we have to find an alternative route. Now, the alternative route is to actually form gaseous ions of this ionic solid. So we need to go from the ionic solid to the gas ions, or if we go from gas ions to ionic solid, what we're looking at by definition is the lattice enthalpy of formation, or LEF. We can also take those gas ions and dissolve them into water. We don't call it dissolution, we call it hydration. So these will have hydration values, or enthalpies of hydration, okay, also known as the delta H of hydration. So in general, that's the cycle, and as ever, just like we did with other Hess's cycles, we can work out any of these values as long as we know the two of the other values. So for example, with the barium sulfate example, because we can't dissolve it directly and determine the energy change, the temperature change, this route is blocked off to us. So what we have to do is take the alternative route, which would be round this way. Now that would mean that our delta H of solution for our substance would be equal to the negative of the lattice enthalpy of formation, because we're going against this arrow, and then we go with the next arrow, so it's going to be plus the delta H of the hydrations of the gas ions. And I think that's it.